Hello everyone, in this video we are going to build a function that solves the Sudoku game. The objective is to fill a 9x9 grid with digits so that each column, each row, and each of the 9 3x3 subgrids that compose the grid contain all of the digits from 1 to 9. This is an example. We have 9 rows, 9 columns, we have some values, and we have to fill for the missing values. So let's reproduce this example. We write a matrix. NA stands for not available, that is for the missing value. And as you can see, for example, here we have missing value, missing value, missing value, missing value, 2, 1, missing value, 3. And this corresponds to the first row here. And this is a 9x9 matrix. So let's run. So this is the Sudoku that we want to solve. And as you can see here, I have already loaded the function, so I can solve this Sudoku. I run this function. And this is the solution. Let's check. For example, this is the first row. We have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Let's check the first column. We have, for example, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Let's check the first box. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this seems that solution is correct. We can check for the speed. So this was solved in 0.3. Now it's time to write this function. So we write this function in blocks. The first block we write this function is possible. This function determines if we can assign a value at the place of the missing value. And this function is built in 3 subblocks. Subblock number 1, we write the function is in row. This function checks if the value is in the rows. So is in row takes 3 arguments. X is the Sudoku that we want to solve, the row index, and the number that we want to test. If any of the numbers in the row is equal to the number that we want to test, if this is true, the function returns value true. Otherwise, return value false. Let's run and let's test. Let me print again the Sudoku. This is the Sudoku that we want to solve. So we are testing if in this Sudoku, in row 1, if there is value 7. Let's run. And here it's false, because we don't have 7 here. But let's try number 1. And as you can see, this is true, because we have 1 here. Now, subblock number 2. We write the function is in call. This function checks if the value is in the columns. You can see this is very similar to the previous one. Takes 3 arguments. X is the Sudoku that we want to solve, but now takes the index for the column, and this is always the number that we want to test. If any of the numbers in the column is equal to the number that we want to test, if this is true, the function returns value true, otherwise return false. So let's run. And now let's test if there is a 7 in the first column. If here there is a 7. This is false. Let's try with 8. And this is true, because we have 8 here. Now, subblock number 3 is in box. This function checks if the value is in the boxes. And this function is a little bit more complicated, and we're going to explain in details in a moment when we break down the function. Now, function takes 4 arguments, the Sudoku that we want to solve, the row index, the the column index and the number that we want to test. And basically, this code here uh, determine this code here determines based on the row and column indices which box we are testing. And as I said, for the moment, let's run this and we are going to explain later. So, for the Sudoku, for the row 1, column 1, we are checking if there is number 7. So the answer is false. And the reason is because this row 1, column 1 is identifying this box here. This is the first box, basically. If we try, for example, 6, the answer is true because in this box here, we have a 6 here. Now, let's put all together. So, the function is possible, takes 4 arguments, the sudoku that you want to solve, a row index, a column index, and the number that you want to test, and check that if the previous function is in row, is in call, is in box, if they are all false, return value true. This means that it's possible to assign that value for that specific cell. So let's run. Let's test. So we are testing row 1, column 1. If it's possible, assign value 7, and the answer is true. Now, block number 2, we write the possible numbers function. Basically, this function pick up all the possible numbers that can be assigned to a specific cell. So it takes 3 arguments, the sudoku that we want to solve, the row index and the column index. N here is an object that stores a sequence from 1 to 9. Basically, from 1 to 9, they are the numbers that can be assigned to a given cell. Then generates an object, P, and we initialize this object with a missing value. And the loop starts. And for num in n, where n is this sequence, this num we can write any name. Usually you can find I, for example. So for num in the sequence, if it's true that it's possible, this function, if this is true, basically we append this number to the object P. After this is complete, P is returned as complete case. Basically, we are removing this missing value. So let's run. Now, let's check all the possible numbers that could be assigned to the cell 1, 1. So row 1, column 1. And the number are 5, 7, and 9. And as you can see, before we check for 7, so we knew that 7 could be assigned, but now we know that also 5 and 9 are possible numbers for that cell. And now basically we have done, because we can run now the sudoku solver function. So this is all the function. So basically the sudoku underscore solver takes one argument x, that is the sudoku that we want to solve. This is the check. Basically, we are checking if there are missing values. If there are no missing values in X, this means that the Sudoku is complete and the function returns the Sudoku complete. Otherwise, this is the first step here. This code here locates missing values, and those missing values are stored in the object df. So which is missing values in X, and this part of the code here return the row index and the column index of the missing value. Now, row is an object that corresponds to the first row, first column of df. So basically this is the value that is stored in row, and col is the value from df that is from row 1, column 2. In these two objects, they become the arguments of the possible numbers function. And as you can see, these record the possible numbers. For example, in the first case, in the first example, there were 5, 7, and 9. So now the loop starts. So for I in P, so let's say that the first number is 5. So 5 is assigned here. It's assigned to X row, that is this value, and column, that is this value. And now notice that the function is calling itself. So basically, this is the function, and then we have the function that calls itself. Why? Because we are checking that the value that we assign is correct. If it's not correct, what happened? Happened that the value is returned as null, but we are inside the loop. Notice here, this is the loop. So what really happens is that the loop tries the second number in P. If 5 is not the correct number, the function check the second number, in this case 7. So 7 is assigned to the same location. If that is correct, the function will call itself. So as you can see, this is a recursive function. Basically, this will solve the Sudoku. Let's run this function here. Let's solve another Sudoku, and then we break down the function, and everything will be clear. Okay, let's try a more difficult Sudoku. This is the Sudoku that we want to solve. We store the solution in rest. Let's run. And this is the solution. Now, we know that the number from 1 to 9 is sum to 45. So I'm checking that all the rows sum to 45, and also all the column sums to 45. So basically, solution here is correct. So now we can check the speed of implementation. Was 1.20. I think not bad. Let's break down. And for this, we use a simple case. Let's solve this Sudoku. So as you can see, we have very few missing values here. Let's solve it. It is the solution, and as you can see, has been very fast. So now let's do manually. So what we are doing, this is the Sudoku that we want to solve. So we assign the Sudoku to X. So now X is the Sudoku that we want to solve. Now it's time to explain the isInBox function. Let's check. Row 1, column 1, if we want to check number 7. So now you have to think that we are in the isInBox function. So the first is to generate this object, box underscore row. Row now is 1. 1 minus 1 is 0. And we are making this operation, that is the integer division. And this will be 0. In this case, we have 0 integer division 3. This is 0. So let's run. And as you can see, this is 0. For the box underscore call, this part is also 0 because in this case, also call is equal to 1. But now we are adding 1, 2, and 3. So in this case, box underscore call is 1, 2, and 3. And now we are here. Notice that box row, we say that is 0, but we are adding 0 plus 1. So basically, we select only this part of the code. It's returning NA, NA, NA. Why? Because 0 plus 1 is 1, so this means row 1. But only column 1, 2, and 3. So basically, this corresponds to this part of this matrix. This one, if we run, you can see it's again NA, 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 but now we are here, row 2, because box underscore row is 0, but 0 plus 2 is 2, and box underscore call is 1, 2, and 3. So we are here, row 2, 1, 2, and 3. We check this. Okay, NA, 8, and A. We have this. Why? Because box underscore row is 0 plus 3 is 3. So this means row number 3. And then we have 1, 2, and 3. The values stored in box underscore call. Now, I slightly modified the function because we cannot use return in this context. So I'm using the if function and print if this is true. Basically, if this value here is equal to the number that we are testing, returns value yes, otherwise no. So if we check, the question is 7 in the box? And the answer here is no. But if we try 8, is 8 in the box? And the answer is yes, because we check 8 is here. For example, let's change the number. Let's say row 4 column row 5 column 4 number 8. So now if we run this corresponds to 3. This, because we have row 5, 5 minus 1 is 4, 4 integer division, the value that is returned is only 1 here, and now 1 is multiplied by 3. So here box underscore row is 3, and in this case here this is 3, but now we are adding 1, 2, and 3. So this means that in this case value are 4, 5, and 6. But again, box underscore row is 3, but the value is 3 plus 1. So basically, the value returned are 147 because we are here. We said box underscore row is 3, 3 plus 1 is 4, row 4. And we say that box underscore call is 4, 5, and 6. So this, we are identifying the box with this computation here. Now let's analyze the sudoku solver. Let me show you. Again, this is the function. So we are going to implement manually each step. So we are taking this code and implement manually. So we are checking for the missing values. This is the first check. As you can see, this is false, basically. This exclamation mark corresponds to negation. So this means that we have missing values in X. This is the first step. So the second step here is to locate the missing values. So let's run. And as you can see, these are the location of the missing values. Let's see. Row 1, column 1, missing value. Row 2, column 1, missing value. Row 3, column 1, missing value. Row 6, column 1, missing value. Row 1, column 2, missing value, and so on. Now, as you can see, the second step here is to assign the values to row and col. And it's always the same value that is assigned. From df, from this object, we are taking row 1, column 1, this means this one, and row 1, column 2, it means this one. So basically, in this case, row 1, column 1, now they become these two arguments from possible numbers. So when we run, we have these three possible numbers. Let's check the solution. We know this is the solution. And now what happens? As you can see, these are the three possible numbers. But as you can see, 4 is not the right number. Now we are inside the loop. For I in P, the first number in P is 4, so we have to assign 4 here. But as you can see now, this is not the correct number. If we call the function now, this is the next step, what happens? Is that the function returns value null, because this is not the correct number. So we could not solve, but we are inside the loop. So this part of the code is not implemented. So what happens is that the loop check for the second number in P. The second number in P is a 7. So basically, it's doing this. Now, as you can see, 7 is placed in the right cell. And when now the function calls itself, as you can see, this is the solution. So this is what the function is doing. This is a recursive function where the function is calling itself. Now I want to show you all this step manually again. So let me reset here sudoku. Now this is the first check. These are the missing values. The possible. Now we already know that the first one is 7. Now let's not run this part. Let's do manually. The function is called itself. So what does it mean? That the first step is this one. The function is doing this. And now, note what happened. These are the missing values. Now, 1, 1 is not here anymore. Why? Because x has been updated. So we have 7 in 1, 1. So when this function here runs again, this is not a missing value anymore. So these two 1 that here was located are row number 2 now become row number 1. And this is the reason why we have this always set to 1, 1 and 1, 2. Let's take these values here. So 3 and 9. Let's place 3. This is the correct answer. So now the function here calls again itself and does this. Now again, 3 is the number here. So here we don't have 2, 1 anymore because this is not a missing value anymore. And 3, 1 that was here now is located at 1. And if we go back, 3, 1 was located at the beginning at 3. So this is what the function is doing. So we can continue here. I think the number was 4. And then continue until everything is filled. So I hope this is useful. If you have any question, feel free to write in the comment section. And if you enjoyed this video, see you in the next one.